What up, my dudes? It's Mr. Rowan here, and today we are going to be talking about triangles, Unit 4, Day 2, particularly inequalities, and we're going to be looking at the relationships between some sides and some angles. So, first of all, let's check out some of the basics. So, we've got this triangle ABC, and so we're looking at angle A. So, when we say the sides that are adjacent to angle A, we mean the sides that include the point A. So that's AB, and then the other one would be AC. And again, you can say it as as AC or as CA. So I'll write it as CA just so you know that point A doesn't always have to go first. And then when we're talking about the side that's opposite to angle A, we just mean the one that's not included. So to help you see, we're going to cover up angle A, and then which side can we see the whole thing? Well, that's BC. It's the one that doesn't include A. So now A, B, and C are going to be what we call vertices. So if there's just one, it's called a vertex. But if there's more than one, or three in this case, then we call them vertices. Now, when we talk about included angles, when we talk about AB and BC, when we have two sides, well, we basically just mean the angle that those two sides form. And so AB and BC will form an angle with B in the middle. So angle B. You could also call it angle ABC or CBA, but we'll just say that. And then the included side of two angles is the side that connects them, so AC. Alright, so we're going to move on a little bit. And we're not going to use a ruler for this next section. We don't really need to. You can if you have one at home, just to help you out. But we're just going to use a theorem that we understand. And so when we start with the smallest angle, this one's pretty easy because it's actually labeled right here on the diagram. So we've got 32 as our smallest. Then we want to check out which angle is the smallest. And so when we check out the smallest angle, the one that's opposite to that is going to be the shortest side. And you can kind of see this without having to do any math, but sometimes if the figure isn't drawn exactly to scale, it can be hard to tell. So the shortest side here is BC. So it's opposite the smallest angle. Next, we're going to look at angle B, and the side that's opposite to that one, angle A, angle B, and the side that's opposite to that would be AC. So I would really encourage you to have your colored pencils out while you're doing this so that you can draw across to the opposite side. And then angle C is of course the largest angle, which means that the opposite side to that is the longest side. So AB would be the longest side in this case. I think you can probably figure out this angle on your own, but notice how it's going backwards. It's going from longest to shortest. So it's really key that you read the question here, because you might see a question like this on your test or on the SOL, and you have to make sure you're going in the direction that they want you to go in. Now, here's our more formal definition. If one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So what that really means is that the shortest side is going to be opposite. Well, we wouldn't really say the shortest angle, we would say the smallest angle. And then conversely, the longest angle is opposite the longest side. It's opposite. Yeah, the largest angle. It's opposite the longest side. So you see it goes both ways. You can say, you can use an angle to find a side, or you can use a side to find an angle. So, yeah, we're going to make these labels a little bit bigger. So that way we can see what should be the longest side. So obviously the longest side here would be 16. So that would be ML, the angles or the sides. So then angle N would be the largest angle. Next we're going to look at NL, so opposite of that would be angle M, and you can guess what comes last. It is side NM. Then we have an arrow pointing at angle L. Now we're going to be, for this one, we are going to be combining what we've just learned in the last unit with what we're learning in this unit, which is that all the angles in our triangle have to add up to 180. So in order to complete this problem, we have to make sure that we know the measurement of the last angle. So you guys can do that one on your own. So, and we'll be doing practice problems like that a little bit later. Okay. So here's the next thing that we'll be learning about. So you can check if three given lengths form a triangle by adding the smaller two sides. If the sum is greater than the longest side, then the given lengths can form a triangle. So not all side lengths are going to be able to form a triangle. So let's check. 3 plus 3 is 6. 6 is greater than 3. And so that works. It's possible. In fact, that would be an equilateral triangle. Now let's try this. Let's try the next one, 3, 4, and 8. So 3 plus 4, is that greater than 8? 3 plus 4 is 7. 7 is not greater than 8. So, yeah, that one doesn't work. Not possible. Okay. So let's try a couple others. Let's try 10, 5, and 5. So 5 plus 5 is greater than 10. Nope, not last time I checked. So 10 plus 10, or sorry, 10 is actually equal to 10. So nope, it doesn't quite work. Remember, it has to always be exactly greater. And we'll kind of investigate why that is the case in class, in case it's not intuitively obvious. And we're going to go down and do a little bit more. Okay, so here's our official definition. The length of any side of a triangle must be greater than the difference between the other two sides, but less than the sum of the other two sides. So we've got one side that is 10 and one side that is 14. So let's first find the sum, and then let's find the difference. So 14 plus 10, that'll give us 24, and 14 minus 10 will give us 4. And then when it says to describe the possible lengths of the third side, what we want is an inequality. So x has to be less than 24, and x has to be greater than 4. So we can just write this as this compound inequality, where x is in between 4 and 24. So let's take a look at AB. Okay, and I think you can do this one on your own. You can do these other ones. So I am going to sign out, and we will do some practice with this in class. Enjoy the rest of your weekend, everybody.